Hello, boys and girls. Today we're going to talk about the mathematics chapter, that is powers, powers and exponents. Powers and exponents. Okay, so this is also called indices. Okay, so for example, if you have to do 3 plus 3 plus 3 plus 3, what will you do? You don't sum up, right, individually, like you don't do the sum of these two and you add again 3 to it and again you add a 3 to it. Instead of that, what you do is 3 into 4. So this is the simplest way of doing such a repetitive additions. So in this case, the answer is 12 because you simply multiplied 3 with 4. Thereby you got an answer 12. Okay. Say if you have to do a repeated multiplication, say for example 3 into 3 into 3 into 3. In mathematics, there is a shortcut. There is a shorter way of writing such a repetitive multiplications. So if a number is multiplied by itself like this for several times, the simplest way of writing this is that 3 to the power of 4. In this case, 3 gets multiplied by itself for 4 times. 3 multiplied by itself 4 times. So the shorter way of writing this one is a 3 to the power of 4. So this is called indices form or index form of a number. So when you evaluate this number, you will get 3 3s are 9 and here 3 3s are 9, and if you multiply 9 with 9, you get an answer of 81. Okay, so the 81 can also be written as 3 to the power of 4. This is the number in general format and this is the equivalent number in index format. Okay, so 3 to the power of 4 is a number in indices form, is an index form. So in this case, when I write 3 to the power of 4, the number here at down is called the base. Okay, so in this case 3 is the base and the number at the top, top is called the power or an index. The 4 is the power or index or exponent or exponent. Okay, so for example, if I tell you to find out the value of x to the power of a, in this case both are unknowns. If somebody tells you to evaluate the value of x to the power of a, what you have to do is you multiply x by itself for a times. Okay, so like this you have to multiply x by itself for a number of times. Okay, so this is the number in index form, and if a number is given like this, and you need to find out the value of that using this mechanism. So we will evaluate the different numbers having a different basis and a different powers. Okay, again a number is called, this number is said to be written in indices form when it is having a base and when it is having a power. The power is also called index or an exponent. Okay, so there are certain identities when you are evaluating the numbers in a indices form. For example, the very popular form is that 3 to the power of 0. Okay, so this is called an identity. So any number raised to the power 0, the value of that number is 1. Okay, so no matter what we have here, it could be a positive number, it could be a negative number, it could be a fractional number, or any number raised to the power of 0, we get to 1. You don't have to worry too much how we got to 1, but there's a whole lot of derivation there as how we got to 1. But all you have to do at this level is just to remember any number raised to the power of 0 is 1. It's not only 3 to the power of 0, it could be 100 to the power of 0 is 1. It could be 3 by 4 to the power of 0 is 1. It could be minus 8 to the power of 0 is 1. So the identity here is x to the power of 0 is 1. Okay, x could be any number. It could be positive number, it could be negative number, it could be a fractional number or any number. Okay, it doesn't matter. Any number raised to the power of 0, you'll get the answer is 1. Okay, you have to remember that one. Okay, this is one format. This is evaluating the numbers given in a indices form with the different bases and the different powers. So here the power 0 holds a very significant while we're dealing with powers and exponents. So any number raised to the power 0, you will get 1. For example, 1 is raised to the power 1 to the power of 5. So what is the value of 1 to the power of 5? It is 1 into 1 into 1 into 1. So that is, you know that it's going to be 1. So 1 raised to the power 5 will get 1. For example, 1 raised to the power of 10 is again 1. Because 1 into 1 into 1 into 1, like that, if you multiply for enough 10 number of times, you will get the answer 1. Again, 1 raised to the power of 0, you get 1. Okay, so this is the same as here. Any number raised to the power of 0, you get 1. So 1 is not an exception for it. Even if you raise 1 to the power of 0, you will get 1. Okay, so 1. Yeah, that's pretty much it. Let us stop here, and we'll also see the negative powers and all as we go along. So for now, the 1 raised to the power of a positive power or a negative power, you'll get the answer 1. For example, 1 raised to the power of 1 to raised to the power of minus 5, you'll also get a 1. Okay, so how to evaluate the number with a negative power, we'll study. We'll study next. Okay, so 1 raised to the power of any number, that n will get a 1. Okay, so there are two identities that we learned. One is x to the power of 0 is 1, and 1 to the power of n is a 1. Okay, okay, so this is how to evaluate numbers with that are having a different bases and different powers. Okay, and the next one is, for example, if a number is raised to the power by a fractional number. For example, I would say 16 to the power of 1 by 2. Okay, so here the base is a positive number and the power is a fraction, which is 1 by 2, which is 0.5. Okay, how to evaluate this number? So this basically tells that if a number is raised to the power to a fractional value, the way it's supposed to be written as, this is also equivalent to square root of 16. Okay, square root of 16. The value of square root of 16, how to evaluate any square root is that any number, if it is multiplied by itself, if you get this number in the number that is under the square root, then that number is called the square root of this number. So in this case, how do we get a 16? When you multiply 4 by itself, you will get a 16. So the 4 is an answer for this one. Square root of 16, the value of square root of 16 is 4. Okay, so the perfect way of writing this 1 by 2, power in 1 by 2 is putting a 2 here. If nothing is mentioned here, it is a square root. For example, I'm going to give you another one, 27 to the power of 1 by 3. Okay, so the way it should be written as that there's a positive number here and the power is this positive number at the base and the power is the fractional number. To evaluate this such kind of indices numbers, the way it should be written as 3 here and 27. This is called as cubed root of 27. Cubed root. Here it is 2 here, that is why you call a square root. Here it is 3, that is why you call it as a cubed root of 27. The cubed root of 27, the way how it should be computed or calculated is that any number, if you multiply itself multiply itself for a 3 number of times, you should get this 27. In this case, what is the number? If you multiply by itself for a 3 times, you'll get 27. 3 is that number. Say 3 3s are 9, 9 3s are 27. So that is why answer is here 3. So a number, for example, 64 4 to the power of 1 by 4. 64 to the power of 1 by 4. This can be written as 4th root of 64. Okay, whose value is again the 4. How we got 4? 4 if you multiply by itself for 4 times, like 4 into 4 into 4 into 4, we get a 64. The answer is 64. So this is another way of calculating array computing the numbers that are having a fractional powers. Okay, a fractional powers. For example, if somebody gives you 8 to the power of 8 to the power of 8 to the power of 2 by 4. Okay, we'll come to that one later. Yeah, but for now you just learn that any number that is having a fractional power, this is how you have to calculate and find out the value of that number. Okay. Okay. So in generic way, how this can be written as x to the power of 1 by a or 1 by n is equal to nth root of x is equal to nth root of x. This could be 2, this could be 3, this could be 4 or anything. So it could be anything, but that nth root of x is the answer, is the equal to x to the power of 1 by n. Okay. Okay. The very first thing that we learned is x to the power of a is equal to x into x into x into like this a number of times, a times. Okay. So I am also putting this one here. X to the power of a is equal to x into x into x into like this a times. Okay. Now, so another important identity is that, say for example, if a number x is raised to the power of minus a, how to calculate such numbers? Okay. So I take an example, 2 to the power of 2 to the power of or 64 to the power of minus 3. To make it simple, 4 to the power of minus 3. Okay. So the way how it should be calculated is that the value of this one, any number raised to the power of negative number, is 1 by 4 to the power of 3 in this case. Okay. So here we are raising 4 to the power of negative 2 minus 3 power. So this is also equal into 1 by 4. So you know the value of 4 to the power of 3, which is 4 4s are 16, 16 4s are 64. So 1 by 64. So 1 by 64 is the value of this one. To write it in a generic way, again, x to the power of minus a can be written as 1 by x to the power of a. Okay, this is again important and you need to remember this formula. This is also another identity. So x to the power of a is equal to 1 by x to the power of a. Okay. Also, it's also important that, see, in all these cases we're taking the positive basis here. So here this is 1 anyway, here it is x, here it is x, here it is x, and in all these cases we assume the base is a positive base. For example, if I take a negative base, for example, if I say 2 to the power of minus 2 to the power of 3, the way how it should be calculated is minus 2 into minus 2 into minus 3, minus 2. So the value of this one is minus into minus plus, plus into minus minus. So minus 2 2s are 4, 4 2s are 8. So you got an answer of minus 8. So okay, Yeah. So to summarize this one, such calculations, any negative number, raise it to the odd power, you will get a negative number, Okay. So to generalize this format, minus x whole to the power of n is equal to minus x to the power of n, where n is odd, if n is an odd, or it is going to be x to the power of n if n is even. Okay, so how we got this one? Say for example, instead of raise it to the power of 3, if I raise it to the power of 4, so what I'm going to get here, minus 2 multiplied by itself 4 times, minus 2, minus 2, minus 2, minus 2. So in this case, you got a minus into minus into minus, plus, plus into minus, minus, again minus into minus, you got a plus. Plus 2 2s are 4, 4 2s are 8, 8 2s are 16. Answer is 16. So it's a negative number here. Just raise it to the even power. In such case, you got a positive number and the value of that number is 2 to the power of 4 only. 2 to the power of 4 is 16 and you got a positive number here. So this is another formula or another identity which you have to remember. Okay, if n is not, it's going to be minus x to the power of n, and if n is even, it's going to be x to the power of n. Okay, so this is how you have to calculate evaluate the values of numbers that are given in indices form. Also, another identity, and which is very famous, is for example, if a 10 is raised to the power of 5, value of that one is going to be 10 into 10 into 10 into 10 into 10. So in this case, you got 10 tens are, in this case, you got 100, 1000, 10,000 and 1 lakh. So you got 5 zeros after 1. It's important that it's not a 5 zeros after 10, it's a 5 zeros after 1. Okay, so 10 to the power of 5 is after 1, you need to put a 5 zeros. Okay, so this is another very famous one which you really need when you convert numbers into scientific notation. Okay, so wherein we always deal with the 10 to the power of some power, 10 to the power of some power. So we'll also generalize that one. For example, 10 to the power of n is, if it is like this, so 1 after you need to put n zeros. After 1 you need to put n zeros. Okay. Well, yeah, we figured out the different identities and how to evaluate the numbers that are given in indices form that are having a different bases and different powers. Okay, and the next part is how to compare. For example, if two numbers are given, how do you compare it? The comparison of numbers that are given in indices form. For example, if I tell 2 to the power of 5, okay, before we go to that one, there are also a couple of other identities which are very important that we should learn at this point of time. For example, if I tell 3 to the power of 5 into 3 to the power of 3, how do we calculate such number? The way it should be calculated is 3 to the power of 5, which means that you need to multiply 3 by itself 5 times, and there is also multiplication here. You put a multiplication here, and 3 raised to the power of 3, which means this is also called as a 3 cube. Okay, so the way how it should be calculated is 3 into 3 into 3. So this part belongs to 3 cube and this part belongs to 3 to the power of 5, and we have a multiplication in between. Okay, so this number, this whole multiplication can also be written as 3 to the power of 8 because we are multiplying 3 by itself. How many times? 1, 2, 3, 4, 5, 6, 7, 8. 3 to the power of 8. Okay. So 3 to the power of 5 into 3 to the power of 3 or 3 cube is equal to 3 to the power of 8. If you notice closely, in this case the bases are same. Okay. The bases are same, but the powers are varying here. In this case the power is 5 and in this case the power is 3. In such a case, to evaluate such a multiplication of two numbers that are given in indices form, provided their bases are same. Okay, if their bases are same, what you have to do is you simply have to sum up these powers. In this case, if you sum up a 5, you should not multiply it. Okay, that's very important part. Though there is a multiplication here, you should not multiply it. You simply sum them up. 5 plus 3 will get a 8. So a number that is written in this form can also be written as like this. So again, to generalize formula is that, say for example, x to the power of a into x to the power of b can be written as x to the power of a plus b. Two important things. One is that the bases should be same. Bases should be same. It need not be a positive base or a negative base or any base or a fractional base. But the condition is that the bases should be same and powers can be different. In such case, you have to sum the powers. You should not multiply the powers. Okay, putting a plus is important. At the same time, checking whether they both are having the same basis or not is an important. For example, if somebody tells 5 minus 5 whole to the power of 6 into 5 whole to the power of 8, you should not simply sum 6 plus 8. Okay, because the bases are different. Here it is minus 5, here it is 5. Okay, you need to evaluate this one first, and then you have to apply this this rule. So the generalized rule here is that x to the power of a into x to the power of b is equal to x to the power of a plus b. Okay, on similar lines, there is also another formula. For example, I'm going to take the same example. Instead of multiplication here, I'll take a division. Okay, I'll put a division here. Okay, so this can be written as 3 to the power of 5 by 3 to the power of 3. Okay, 3 to the power of 5 can be written as 3 into 3 into 3 into 3 into 3 divided by 3 cube can be written as 3 into 3 into 3. So this 3 gets cancelled here, this 3 gets cancelled, this 3 gets cancelled. So what you're left with is 3 into 3. This can also be written as 3 square. Okay, a number with a power 2 is called a square, a number with a power 3 is called a cube. This is 3 cube. This can be read as a 3 cube. This can be read as a 3 square. Okay, again, if you notice the pattern here, there is a division. There is the division. Numerator is having a number that is in the indices form. Indices form is a number that is having some base and some power. Okay, numerator is a number in indices form and the denominator is another number in indices form. But in this case, they both are having the same basis. In such cases, the simplest way of evaluating such division is that subtract 3 from 5. Okay, 5 minus 3, what you get is 2. So that's how you have to do this one. For example, to generalize this one again, x to the power of a by x to the power of b is equal to x to the power of a minus b. Okay. There is a division. The bases are same here, x and x. They both are same. It can be any x. Okay, it is x. X is a variable, but in this case, it's a fixed. Both x is same, both on the numerator and also on the denominator. We are having the same base, and the powers are different. In such case, the simplest way of evaluating such a division is that you have to use the same base and do a subtraction with the powers. Okay, the numerator once goes first here and then minus and the denominator 1. Okay, so x to the power of, again I'm writing this formula here, x to the power of a by x to the power of b is equal to x to the power of a minus b. Okay, Yeah, so these are the different formulas that we need to remember, are very important in the due course of learning thousand exponents. Okay, say I'll give you some examples. 100 to the power of 0. What is the answer? Is it a 1? Is it a 100? Is it a 0? Which formula you need to apply? There are several formulas here. So we need to, can you do this one? You cannot do it because there is no a here. There is no a times, this is only 0 times. Okay. The appropriate formula that you can apply here is that this is only the one that I see here. Because I explicitly mentioned a number that is raised to the power of 0. Any number raised to the power of 0 is 1. So in this case 100 is raised to the power of 0. So it is, answer is 1. How we got this formula is a big derivation and you don't have to worry at this point in time, but you should simply remember that any number raised to the power of 0 is equal to 1. Okay, perfect. Yeah. Okay, this is one example. Or somebody may give 5 by 9 whole to the power of 0. What is the value of this one? Okay, again, you don't have to worry about what is there here. What is there as a base? Okay, it is a fractional number, but you don't have to worry. If any number that is raised to the power of 0, will answer is 1. Okay, and for example, I'll tell minus 23 whole to the power of 0. What is the value of this one? It's again 1. It's a negative number, but don't worry, it's rising. You're rising to the power of 0, answer is 1. Okay. For example, okay, I'm also giving some more examples and you try to find out the value of this one. So for example, I said 27 to the power of 1. What is the value of this one? So of course I did not mention anywhere here, but any number that is raised to the power of 1, which means you should apply this one. Okay, so x to the power of a, you're multiplying the same number again and again by itself for a number of times. In this case, the power is 1. That means we have to multiply 27. How many times? Only one time. It's simply 27. Okay. We can also write one formula if required. I'll write it down here. So x to the power of 1 is equal to x. Again, x can be any number. X can be any number. It can be positive number, it can be negative number, it can be fractional number, it can be 0. X can be any number. X to the power of 1 is equal to x. Say for example, I tell 1 by 3 whole to the power of 1 is equal to what? The same rule applies here. I put something in base and it's getting raised to the power 1. The answer is going to be the same here. In this case, it is 1 by 3. For example, if I tell 0.75 whole to the power of 1 is again 0.75. Okay, so this is another formula kind of thing. You can use it while doing it. Okay, fine. Yeah, I'll give some more examples as how to evaluate. For example, 1 to the power of 84. What is the value of this one? Okay, 1 to the power of 84. What is the value of this one? Which formula you're going to apply? The number of formulas here. So the more appropriate formula here is that you should use this one. Okay. These are various kind of questions. You may get an exam to, to find out your ability of understanding of powers and exponents. So in this case, 1 is raised to the power of 84. So this is the formula which you should apply. 1 to the power of n can be anything. In such case, you get an answer of 1. So in this case, the answer is 1. Okay. It need not be 84. It can be anything. 1 to the power of 73 is again 1. 1 to the power of minus 8 is again 1. Okay. Yeah. 1 to the power of 1 by 5 is again 1. Okay. Yeah. Okay. If something is written like this, it can be called, it can be read as x to the power of 2 or x square. Okay, x square is the most common, and any number raised to the power of 2, we usually call it as that number square. Any number raised to the power of 3, we call it as a cube. In this case, this is called as x cube or x to the power of 3, but more often people call this as a x cube. Okay, so the multiplicative inverse of this one is like square root of x. Square root of x. But for x cube, the multiplicative inverse is cube root of x. If nothing is mentioned here, it's implicit that we have 2 here. Okay. So this is a square root of x. This is a cube root of x. Okay, these are not equal, but what I'm telling is this is multiplicative inverse of x cube. This is multiplicative inverse of x cube. What I'm telling is how to read the numbers that are given in this format. Okay, this is called x square. This we read it as x square. This one we read it as x cube. This is the square root of x. This is cube root of x. For example, if somebody says, somebody is written like this. So this is read as x to the power of 13. Okay, x to the power of 13. If somebody written a number like this is fourth root of x. Fourth root of x. For example, if somebody written fourth root of 64. So this is fourth root of 64. Okay, how to evaluate this one? Any number, if you multiply by itself for a 4 number of times, you should get this one. What is that number in this case? It is going to be 4. Okay, yep. And I'm going to give you some more examples. Say 64 power of 1 by 2. Okay, so how do we evaluate such number? So what is the formula that we should apply here? The formula that we should apply here is that this resembles this one. X to the power of 1 by n is equal to nth root of x. So in this case, 1 by n. N here is 2. That is nth root of, that is square root of 64. So the way it should be calculated is, and you find out the number. That number, when you multiply by itself for 2 times, 2 number of times, you should get a 64. In this case, the answer is 8. Okay. Yeah, answer is 8. In fact, it is plus or minus 8, because the reason why I am saying plus or minus 8 is, if you multiply plus 8 by itself, that means plus 8 into plus 8, you will get 64. Even if you multiply minus 8 by itself, plus or minus 8, it's not and, either plus 8 or minus 8. Okay, both answers are correct. If both answers are correct, the reason is that if you multiply 8 by itself, you get a 64. If you multiply minus 8 by itself, you get a 64. Okay. I'm going to give you one more example to evaluate 10 to the power of minus 5. How do you evaluate this number? So what is the more appropriate formula here you should apply? So this is the formula that you should apply. So when a number is raised to the power of negative power, what you have to put is 1 by the very same number with the positive power. Earlier it was a 10 to the power of minus 5, now you are putting a 10 to the power of 5. Okay, 1 by the very same number, and you have to reverse this symbol here. In this case, it is minus 5 and it's going to be plus 5 here. So 1 to the power of 1 by 10 to the power of 5. The value of this one, if you have to find out 1 by 10 to the power of 5, which is again this one you need to apply here. So 10 to the power of n, what you have to do is 1 after, you need to put n number of zeros. So 10 to the power of 5, you have to put 5 zeros here after 1. It's not a 10 after, it's a 1 after, you have to put 5 zeros. Okay, so when you put it in decimal, it's going to be 0.00001. Okay, yeah, the value of this one is going to be this one. It's going to be this one. Yeah, this is one example. Okay, I'm going to give you one more example. Minus 1 whole to the power of 8. What is the value of this one? So which formula will you apply here? The formula that we should apply is this one, because we are having a base of a negative number. So in this case, you need to look what is the power here. The power is 8, which is whether it is odd number or even number. 8 is an even number, so the formula for this one is going to be x to to the power of n. In this case, what is x here? 1. 1 to the power of n. What is n here? This is the n. 1 to the power of 8. So 1 to the power of 8, which is 1 again. For example, if I tell 1 to the power of, minus 1 to the power of 7. In such case, what formula you should apply? Again, the same formula you have to apply. But instead of putting this way, you have to put it this way. The reason is that we have a power of 7, which is an odd number. So it's going to be minus x to the power of n. What is x here? X is 1. 1 to the power of 7. Okay. Again, there's a difference here. There is a difference here. Here you are saying minus 1. Here you are seeing minus 1. Here also minus 1. But the only difference is that the bracket is a whole. The bracket minus is also under the bracket. Here the minus has come out. There is no bracket as such. In such case, the minus will remain as a minus, and 1 to the power of 7. 1 to the power of 7 is 1. Okay. So the value of this one is 1. So like this, somebody may ask, what is 1 to the power of 1? 103. 1 to the power of minus 1 to the power of 103. What is the value of this one? Since this power is a negative number, since the power is an odd number, this is the formula that you should apply. Okay, minus x all to the power of n. In this case, minus, what is x? 1 to the power of 103. So that's going to be again 1 to the power of 103 is 1 minus 1. Okay, so it's important that you have to understand the difference here. Here the minus is also under the bracket. That means when you evaluate this one, you have to multiply minus 1 by itself. Minus 1 into minus 1 into minus 1 into minus 1, like this 103 times. Okay, since 103 is an odd number, you will eventually get a negative here. Because minus into minus plus. There are two minuses you are multiplying. If you multiply 3 minuses, minus into minus into minus, you will get a minus. 3 times you are multiplying the minus by itself, so you got a minus because 3 is an odd number. Okay. Okay. There is also one more identity that I'm going to tell here. Say for example, if some number is written like this, so in such case, how do you evaluate? There is a base and there is a power. There is a power, but the base is also in indices form. In such case, how to evaluate such number is that first you find out what is a 2 cube. Okay, so 2 cube, it's 2 to the power of 3 or a 2 cube. 2 into 2 into 2. Okay, this is 2 cube. Whole to the power of 4, which means that we have to multiply this base by itself for a 4 number of times. So 2 into 2, this is 1 time. This is all 1 time. 2 into 2 into 2, this is all second time. 2 into 2 into 2, this is all third time, and again 2 into 2 into 2, fourth time. Is it that way? Yeah. So 2 into 2 into 2 to the power of 4. So we are multiplying 2 into 2 into 2 again by itself for a 4 number of times. So what this whole multiplication can be written as, how many 2's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2 to the power of 12. Okay, again there is a formula that we can derive from this calculation. So x to the power of a whole to the power of b whole to the power of, it's very important, whole to the power of b is equal to x to the power of ab. You need to multiply both these powers here, 3 into 4. Okay, x to the power of 3 whole to the power of 4, the answer is you got 2 to the power of 12. How you got? The answer is that if you multiply 3 and 4, you got a 12. So the formula here is that x to the power of a whole to the power of b is equal to x to the power of ab. Okay, that is also another formula. X to the power of a whole to the power of b is equal to x to the power of ab. Okay. All right. So there is a slightly difference here. So this, you know that I'm going to write this one in a slightly different way. Okay. So what is the value of this one? x to the power of a power of b, x to the power of a power of b. So the only difference is here I put a bracket, here I did not put a bracket. So in such case, what you have to do is you have to evaluate a to the power of b first, a to the power of b first, and then use that number as a power for x. Okay, so there is a difference. It is not equal to x to the power of ab, x to the power of a whole, because I put a bracket here, whole to the power of b is x to the power of ab, but in this case I did not put any bracket. So x to the power of a power of a to the power of b. In such case, you have to evaluate this index number first, a to the power of b first, and then use that as a power for x. Okay, so this is not equal to x to the power of ab. So this is also important thing that you have to remember. When a number is given like this, you can apply this one. If a number is like this, to evaluate that number, you need to find out a to the power of b first, and then use that as a power for x. Okay, for now we'll stop here. In the next class, we're going to discuss how to simplify numbers that are given in indices form, and we'll also find out how to compare the two numbers that are given in indices form. Okay, how to compare, say for example, if two numbers are given, how do we find out which one is a bigger, which one is a smaller, whether they both are equal or not. That we study in the next class. Okay, and before I wrap it up, first of all, what is the need for writing any number in indices form or index form? The reason is that there are some numbers that are very big. For example, what is the velocity of light? It's going to be 3,000, I think 3 into 10 to the power of 8, so 5, 6, 7, 8 meters per second. Okay, so the velocity of light is equal to this one. This much, such a big figure. Okay, yeah, that's meters per second. So often if somebody written like this, it's always there is always a possibility that you may tend to count how many zeros are here. So you should be very careful in counting the number of zeros. So it's 1 0 2 0 3 0 4 0 5 6 7 8 zeros are here. Okay, so if you are far away from the board, and there is a possibility that you may miscount the number of zeros, and instead of putting 8 zeros, you may put a 6 zeros, or instead of putting 8 zeros, you may put a 9 zeros. So there is chances of error there. So to prevent such errors, these indices, the numbers in indices forms are very helpful. So instead of writing this one, you can simply write this number as a 3 into 10 to the power of 8 meters per second. So this clearly tells that 3 should be multiplied by this number, and this number is having 8 zeros after 1. Okay, so you don't have to count like how many zeros are there, so whether there is a possibility of missing out 1 zero or adding one more zero. So there is no such possibility. But if you write the same way, the very same number as in this way, it's very easy, and there won't be any possibility that you may go wrong. So 3 into 10 to the power of 8. So often any numbers in the scientific terminology, some numbers are very big, some numbers are very too small, tiny small. So such numbers, to represent such numbers, we use this indices forms of numbers. Okay. Yeah, before I wrap it up, I'll also tell that, say for example, if somebody asks you what is the value of 10 to the power of minus 3, which formula you use this one out of these 3? So this is the one which is matching to this one. So 10 to the power of minus 3 is 1 by 10 to the power of 3. Same thing. X to the power of minus a is equal to 1 by x to the power of a. Here a is 3 and x is 10. So 1 by x to the power of a. So 1 by 1000. So 1 after 3 zeros. It's not 10 after 3 zeros. It's 1 after 3 zeros. 1 by 1000. That is going to be 0.000. So like this. So one important thing, a positive number more than 1, if it is raised to the power of negative power, you will get the value always less than 1. So it can be any positive number. You pick up any positive number, for example 3. If you raise to the power of minus 2, that's going to be 1 by 3 square, that's going to be 1 by 9. Okay, 1 by some number, some positive number, you'll always get a value 0 point something something like this. Okay, so any positive number more than 1, if you raise it to the negative power, you'll always get a value that is less than 1. Here this is less than 1, here also you get something which is less than 1. Surely you'll get a less than 1. Okay, you pick up any number, 13 to the power of minus 8, that's going to be 1 by 13 to the power of 8, that's going to be 1 by some big number will come here, and 1 by that big number you'll always get a 0 point something, so which is less than 1. Okay, these are various tricks that you have to notice while you're dealing with this numbers and powers and exponents. Okay, and yeah, so any positive number, so 1 and 0 the exception. For example, 0 to the power of minus 8, you'll get a 0. You'll get a 0. Yeah, so that this is also another form that we can put in somewhere here. So 0, it should have fit in here. So 0 to the power of n is equal to 0. Okay, 0 is an exception here, and 1 is also an exception. The reason why I am saying this number should be more than 1 is that, for example, if I take 1 to the power of minus 8, it's going to be 1 by 1 to the power of 8. Okay, that's going to be 1 by 1, that is equal to 1. So 1 to the power of minus 8 is 1, 0 to the power of minus 8 is 0. Okay, so 0 and 1 are an exception. Any number you pick up, any number that is more than 1, if you raise it to the negative power, you will get a value less than 1. Okay, that's one thing. And also, before I wrap it up, I tell one more thing. Say for example, 2 cube, whose value is 2 into 2 into 2. Okay, we are multiplying 2 by itself for a 3 number of times, whose value is 2, whose value is 8. So a 2, a number more than 1, is raised to the power of raised to a power more than 1 again. In such case, you get a number whose value is more than 2, whose value is always more than 2. Okay, for example, 7 square, which is equal to 7 into 7, which is 49. So this number is raised to the power of 2, you got a 49, which is more than 7. Okay. For example, 16, for example, 4 cube. Okay. A positive number raised to the positive power, both are more than 1. In such case, you got an answer of 64. So that is 64 is more than 4. Okay. So 2 raised to the power of 3, you got 8, which is more than 2. 7 raised to the power of 2, you got 49, which is more than 7. 4 cube, you got the answer 64, which is more than 4. Okay, keep that aside. Say I'm going to tell you 0.1 whole square. What is the value of this one? So the only difference here is I picked up the numbers here as the bases that are more than 1. I picked up number here that is less than 1, but more than 0. Okay. So if I have to evaluate this one, the answer is going to be 0.1 into 0.1, that is going to 0.01. Okay, whose value is more? This value or this value? This value is more. We got a lesser value. So we got a lesser value. Okay, so for example, 0.2 whole cube is equal to 0.2 into 0.2 into 0.2, whose value is 0.008. Okay, whose value is more? This value, this value. This value is more, this value is less, is far less. Okay, far less. Okay, so what is the difference here? I picked up the base, the powers are here and here both are same, like more than 2, more than 1 only. Here I picked up 3, here I picked up 2, here I picked up 3, 2, 3, that's fine. The powers are fine in both the cases, more than. But the base here is a positive number more than 1, 2, 7, 4. Here it's a positive number, but the value of the base is between 0 and 1. So in such case, you get a value that is lesser than this one, lesser than this base here. Here 0.2 whole cube, you got an answer which is 0.008, which is far less than 0.2. Okay, that also you have to remember. Any decimal number that is between 0 and 1, if you raise it to the power more than 1, the reason why I am saying more than 1 is, for example, if you put 0.8 to the power of 1, it's going to be 0.8 only, it remains same. For example, 0.8 whole to the power of 0 is 1. It's not a 0. Okay, 0.8 whole to the power of 0 is 1. Okay, the reason why I am saying is that it should be more than 1. The power should be more than 1. If a power is more than 1, in both the cases, the power is more than 1. You got an answer that is far less than the original base. The base. Okay. Yeah, these are different techniques that you have to remember, that how the value varies. Like if you raise it to the power of power, if you raise to the power of 0, what will be the value of it? If you raise to the power of n, what will, if you raise to the power of a, what will be its value? Like if you raise to the power of positive power, what will be its value? So the different numbers, if you use the different numbers as a base, different numbers as powers, value will drastically vary. For example, if you put this one, as I explained previously, x to the power of minus a is equal to 1 by x to the power of a. If this is a positive number more than 1, and if this is again a is a positive number more than 1, we get a 1 by x to the power of a, but whose value is lies between 0 and 1. Okay, yeah, for now we'll stop here. In the next class we'll see how to compare the numbers that are given in indices form. That's one thing. And second thing is how to simplify. So for example, if a combination of multiplications and divisions and additions are given, how do you simplify such numbers? How do you simplify such numbers? That we'll talk about. And also the very important concept in powers and exponents is that how do we convert a given number into a scientific number? Okay, a given number can be too big, a given number can be too small, and this is the scientific form of representing such a big number. Okay, but how should we do? How do we convert a number into scientific form is something that we'll learn in the next class. Okay, thank you.